Hello there and welcome to Algebra 1 with me, Nathaniel Shifley. I will be your teacher today. You can call me Mr. Shifley or you can just call me Mr. Nathaniel. People go by both. Now, today in Algebra 1, since it's the first day, I'm just going to be explaining to you what algebra essentially is. Now, this is kind of a question I'm asked a lot, mostly by students. We go through formulas, etc. We go through mathematics, we go through arithmetic, but nobody seems to know what the core concept of algebra really is. So I'm going to break it down for you. Algebra, and I'll be doing this using a concept ladder teaching tool. Let me know how this works out for you. Now, simply put, algebra is a real-world problem-solving concept. It's a way of thinking. It's about finding an unknown concept and putting it into a formula. So it is essentially converting real-life problems into equations and then solving for those problems. Fortunately, a lot of textbooks seem to go straight to the procedures, the formulas, and kind of take away from the fact that these are real-life problems being solved, not just numbers and letters on a piece of paper and other symbols. And yes, algebra does essentially substitute numbers with letters, and then we substitute those numbers with letters. It gets a little confusing, but it does represent something to scale. And what is done on one side of the scale of numbers, if I can pull up an example, is also done on the other side of the scale. So the numbers are both constants. Algebra includes real numbers, complex numbers, matrices, vectors, etc. And we'll be getting to those in later lessons. But for now, all you really need to know is what algebra is. In its simplest form, again, it is about solving real-world problems. So the simplest thing I can think of at the moment is a high school teacher had a handful of apples, and his students eat 8 of his apples while he isn't looking, leaving him with only 9 apples. So how many did he start out with? Well, in algebra, we represent the problem with this. Now 8 here would be it would be the number of apples the students ate. And 9, right over here, 9 would be the number of apples the teacher now has after the students ate them. So what does x represent? You've probably seen something like this before and have no idea what it is. X in itself represents the number of apples the teacher had to begin with. Now, we have no idea what that is. It represents the unknown variable that we're trying to find out. The students ate 8 apples. And so we subtract that from the x, the number we do not know. And I'm going to put emphasis on this. X is essentially a number. It is a number. It's just being represented with a letter. Now, we know that the man was left, or the elementary school teacher was left with 9 after the students ate them. Apparently he had a pretty small class with only 8 students that were hungry. And you're going to see x a lot. X is not a fixed number. It's always going to represent a number, and it's going to keep coming back. So keep in mind, x is not a fixed number, but it represents a number in a problem. The goal in this problem is essentially to find the unknown. So we end up with x equals something. So you see here, we have x minus 8 is equal to 9. We don't want that. We want x to be by itself, and we want this number here to be by itself as well. So essentially, we want to get rid of the negative 8. Now, how do we do this? Well, simple. We use algebra. And again, from this perspective, algebra is essentially solving a real-world problem. Now keep in mind this is solving a real-world problem. And when you apply algebra to this, you're using it like a scale. You want to isolate x by itself, and in doing so, you'll have the same thing on each side of the equal sign. So to isolate x in this particular problem, what we have to do is get rid of negative 8. Now to do that, we take 8 and we add 8 to this side of the problem and this side of the problem. So when we take 8 and get rid of it, we're adding 8 to this side of the problem. What's negative 8 plus 8? It's 0. So that means 0's here, and we can cross this out completely. And what is 9 plus 8? 9 plus 8 will be 17. So, in doing so, we have gotten x by itself, and we've come up with a complete concept of what it is. We get rid of negative 8 by adding 8 to it, but we also have to add it to the other side. Keep that in mind. In this problem, we have to keep adding. We have to keep adding things to both sides, or subtracting them to both sides, and later we'll learn more on how we do this. But we have to do what we do on one side of the formula also has to be done to the other side. So in this case, adding 8 to negative 8 just gives us x, because x will be by itself. And then adding it to 9 will give us 17. And we're left with x is equal to 17. That's your answer. So that is essentially an example of what algebra is. Algebra is real-world problem solving, but it is represented by an equation. And again, textbooks will delve right into the equations, but this is kind of what algebra is about. Now, why would you need this exactly? I know you're thinking it. Why do you need this, like, at all? Why would you need it? Well, to be fair, only you can really answer this question. If you work hard, you might become a mathematician, a math teacher. It might give you a good job. But if you have no real extreme interest in math, then it is more of a gateway for you. It can get you into algebra itself can get you into taking higher maths, and you'll find out later that mathematics does indeed apply to real world situations. Algebra helps you develop a way, again, I may have mentioned it before, algebra is all way of thinking, and it's represented by numbers, symbols, and letters. Now, if you're thinking, you'll develop certain aspects as you continue this, specifically logic, the way you think, the patterns and way you think, problem solving, among all else. Problem solving is a huge aspect of algebra. And above all, deductive and inductive reasoning, cognitive reasoning skills, basically how you think. The more math you have, the greater you have opportunities for jobs in, let's say, engineering. I know some of the guys here would like engineering and physics, building big machines. You've probably seen movies where there's giant robots involved or something. I know some of you here have seen Pacific Rim. I definitely know that. And you can actually get jobs in actuary, physics, computer programming, and I know I have a few computer nerds in here. I know everybody loves computers. But higher math provides gateways to all of these. They all involve problem solving, inductive, deductive reasoning, everything. It is super important to remember this. It involves those problems. So, ultimately, if you do your homework, and if you are determined to stick to certain goals, even if that goal is simply passing this class, you'll stick out in math. But you don't have to do it as a career. I am just saying, though, math is everywhere. You will need to know math to a certain extent. Alright. So, let's delve more into the basics of algebra. Let's do a little more. Take a real situation and turn it into an equation. Again, part of the definition of algebra. Second, finding what the unknown is. Taking a real situation, turning it into an equation, and finding what the unknown is. The apple, how many apples the high school teacher originally had, is an example. Now, here's another real-world situation. Let's take a student from the classroom. Tabitha. Okay, let's go with Tabitha here. Okay, so let's say Tabitha is carrying 20 balloons. Yeah, I see you over there. And who here likes popping balloons? Who here likes popping balloons? I see. Okay, we'll go with you, Tom. Okay, so Tabitha and Tom. Hey, that has a nice ring to it. So Tabitha's carrying 20 balloons. Tom comes along and pops a certain amount of them because he likes popping balloons, and she's left with 15. Well, other than firm scolding, how many balloons did Tom pop essentially? Well, to represent this in an equation, we have to write it down like this. Tabitha originally started with 20 balloons. That's 20 minus x, which is the number that Tom popped, is equal to 15, which is the number Tabitha had left. So, again, x is not a fixed number. It represents a number here. It's what we don't know. So, we need to isolate it. We need to make sure that x is by itself. So, how would we do this exactly? Anybody? Good. We need to bring 15 over here to start with. Now you'll notice x is negative here. Your answer cannot be negative x is equal to something. So to start off, we'd bring 15 over here, and we'd subtract it from each side. So when we subtract 15 from each side, we'll end up with 5 minus x is equal to 0. Now 5 minus x is equal to 0 it doesn't solve the problem yet. So in order to do this, in order to get x by itself, how would we do that? Anybody? Alright. Well, in order to start it off, we'd have to simply add x to each side. Again, what you do on one side of the problem affects the other. So this is 5. So we have 5 here and a negative x here. So plus x brings x over to the other side. And in the end, we'll have x is equal to 5. Now, x is equal to 5 will simply be our answer. So our final answer will be 20 minus x, which is 5, so 20 minus 5 is equal to 15. And again, that is exactly what algebra is. Taking real-world problems and just solving them within the form of an equation. Now, to take up some of the time we have left, I'm going to give you a worksheet. It'll be just 4 problems. It won't be too hard for you, and I will give you extra credit points if you answer all 4 of them, but you only have to answer 3. So I will start by handing each sheet to each student, and then you'll be able to solve. And then if you solve 3 of them, you'll get full credit and extra credit if you solve all 4. All right. I think that's gonna wrap it up. So go ahead, try to solve the equations. I'll pass them out and bring them up to me when you're done. If you need help, I'm available. All right.